Hi everybody. The series of videos you're going to see are taken from my Facebook Live that I've been doing in the evenings of the build of this aircraft. Now, one reason I've done this is it's just so much easier to plug in my webcam to my computer, stream it onto my Facebook. People can ask me questions. So the videos you're going to see right now, you'll notice that sometimes I'm answering questions and it's not me hearing voices in my head. It's actually people on my computer asking me questions while I'm just building things. The reason I've done this is it just got too much work to try to record a video, edit that video. Sometimes I would have to edit sound into it because my camera's audio didn't work good with my external microphone audio, and it just became a pain in the butt. So what you're seeing right now is a series of videos of me building the airplane, but it's through my Facebook Live. Now, these first videos were really crappy quality and the audio was crappy, and as I kind of figured out what I was doing, it got much, much better. So understand the first series of videos you're seeing here are crap quality, but then they get much better toward the end. I have about 24 hours of videos I recorded over the last month and a half, and I'm going to try to get each one of them up as about 30-minute pieces or less here on YouTube. So thanks for watching, everybody. I love all my followers, I love all the emails, and I love all the support. Have a great day and rock on. Okay, everybody, I'm going to go ahead and get started. It's funny, my laptop says it's 9 o'clock, but my phone says it's still 2 minutes till, but what the heck. I'm amazed it's Friday night and we got a bunch of people showing up, so maybe Friday nights are not a bad thing to do. So tonight what we're going to talk about is some really cool things. I'm not really sure where to start because I've been really working the last 2 hours. This week's been really busy with work and family. I just haven't had any time to get into this shop until tonight. But I want to show you a couple of things that I go through in the steps of figuring this all out, because a lot of people look at it and think I get it all figured out when I draw it in CAD, and CAD is just one of many tools for me to figure out how to design. So what I want to start by is, well, first of all, let me explain how this horizontal stab is really going to work. So essentially there's going to be an aluminum tube which is really this far, and in that aluminum tube is going to be the ribs, top skin, bottom skin, a leading edge and a trailing edge. And this will slide into the bearing, and the servo will adjust this as my trim if you watch my other videos. So this will be my trim, and then my elevator will run off a servo. So as I put this together, I decided to cut me out a template and put it on here and measure how much 5 degrees is, because that's how much trim I want to have, is 5 degrees up and down, and I think that's a boatload of trim. Hopefully you can see this with the way the resolution is, but I'll bring it up a little bit closer to the camera. But basically this is going to move 5 degrees negative, 5 degrees positive is the trim on my airplane. If you watch my other videos, you saw how I've already programmed my radio that when I move my trim, it moves the horizontal stabilizer, but it does not affect the elevator. The elevator is independent of that trim. But when you look at this, you think, okay, I understand what you're doing. This makes sense. But then I made this that actually has the elevator on it. Okay? So when I look at this, I think, okay, I've got a longer moment arm. I want to have the servo back here, so I have more mechanical advantage in tilting this. But when you look at where the elevator is, you all of a sudden realize, well, wait a minute, you really don't have all that moment arm. You've only got out to about here. So if you look at the center of this, to the nose, to the tail, this is about equal. So I do have a little bit more moment arm, and then I have to ask myself ergonomically, where is that going to fit on the fuselage? Hang on a minute. Okay, now I'm just making sure no one's asking me any important questions. And good evening, everybody, and thanks everybody for joining. So if we imagine that this truly is the piece, and I hope my resolution of the camera is good enough that you can see that this will be the elevator and this will be the trim. Then, if I have my servo mounted back here where I've got the most moment arm, do I get 5 degrees of trim? And I really don't. I only get about 3 degrees. So I believe the servo is going to have to be up here, even though the mechanical advantage isn't enough. Ergonomically, this servo needs to go in front of the horizontal stab. I also want to show you another neat thing. Oh, another thing about how this is going to work. So basically, the horizontal stab is going to be in two, there's going to be two of these, a left and a right. They're going to slide into the bearing. This is the bearing for the fuselage. So it's going to tilt in this bearing. Okay, this bearing is ABS carbon fiber, 3D printed, but I put a fiberglass sleeve in as the actual bushing. Well, I shouldn't say bearing, I guess I should be saying bushing. But what's going to tie these two together inside the fuselage is a fiberglass sleeve that I'm going to slide on, and I'm going to put bolts in this to tie the entire stab into one piece. The reason I'm going to do that is I've only had one servo. I need to knock on wood here. Shoot. Here's some wood. Okay, I've only had one servo really go wonky on me in the last 20 years. However, if the servo that controls the trim of one of these horizontal stabilizers go wonky, you know, 5 degree deflection on one of these, I don't know if I'll have enough to counteract it on the other side. And I would have to be using the trim really quick because I don't know how much elevator authority I'd run out of. So by tying these together at the link, if one servo decides to go nuts, at least it's stalling against the other servo for the trim, not the elevator. My elevators will be separate. There'll be 2 servos for each elevator. But on the trim, since I'm only going to have one servo that's going to tilt this trim, I don't want that servo to have a chance of going wonky and all of a sudden just give me 5 degrees or 5 degree positive or negative trim, because it's going to give me a roll input, plus I just don't know if my elevator would be enough to override it. So that's one reason I'm going to attach these inside the fuselage. So basically, this is the left-hand side will slide into the left-hand side of the fuselage. The right-hand side is going to slide in from the right-hand side of the fuselage, and they will be held together with this connector tube inside the fuselage. So bushing and mount, bushing and mount, and then this connector tube, and this will all become one stabilizer. Okay, so now I've kind of built myself into a box because because of the track cavity I've mounted for my door under here, I don't have a lot of room, so I'm going to have to build some access hatches to be able to install this connector tube. I want to show you another neat thing that I mean, it really sounds simple, but when you buy, hang on a minute. When you buy one of these hole saws, unless you build a jig, foam isn't strong enough for your pilot hole not to wander. So it's really hard, unless you build a jig on a drill press, to drill perfect holes with this. And I have tried everything without building a plywood jig, which I just don't want to spend that much time to figure out how to make perfect holes. But I've figured out how to make perfect holes. I just took a piece of aluminum here, sharpen that down to basically a Ginsu edge. Okay, so right here is like a Ginsu edge. You see this piece of foam here, okay? If I have it marked where I want to put it, I basically start and feel it go through, and then I just start turning it and pushing down until I hear it pop. And once it pops, isn't that a freaking perfect hole in the foam? I mean, that is absolutely perfect. And the cool thing about it is it is airtight. I mean, when I put Gorilla Glue in that, it's going to be stronger than crap. It's going to be really, really strong. So it seems so basic, but it took me a long time to figure out how to do this. And to get the piece of foam out, you just take a piece of all thread or something and pop it out. So if you look at all of these ribs I've made tonight, they all have perfect holes in every one of them. And that's really exciting for me. Just so you kind of understand what's really going to go on here is the top skin is going to be the same material as this. The bottom skin is going to be the same. On the back, I'm just basically going to cap it off, and then I'm either going to stack this stuff up and hot wire cut the trailing edge, which will be the elevator. But I got to warn you, and I'm sure somebody's figured this all out. I have hot wire cut a lot of white foam in my life, and you can kind of smell it, but in a well-ventilated room, it's no big deal. I read all over the internet that this stuff is almost like cyanide when you cut it. I've cut it in a I've hot wire melted it in a very well-ventilated room, and this pink foam wasn't that hard for me to cut. Now, I don't know if 5 years from now I'm going to have some kind of explosive cancer in my brain, but this stuff, hot wire, is really nice. But keep it in a really well-ventilated room or your garage. You know, I'm lucky because I got some Grizzly air handlers in here that suck the air out, runs them up some tubes into my attic, and blows them out basically on my driveway. But I'm really excited about how these holes are working, and it's really, really neat. So that's kind of my update tonight. What I'm wanting to do tomorrow is build the 2 horizontal stabs. Sunday, Monday, Tuesday, and Wednesday I'm traveling for work, and that's my last traveling for the year. And I'm pretty busy the rest of the year, but I'm taking that week between Christmas and New Year's off, so I'll get a lot of building done then. I have changed the design of the aircraft again. It's only going to have 3 engines. 3 motors. I'm sorry. I've had a lot of people point out to me that electric motors are not considered engines because engines are internal combustions. But a lot of my Brit friends said that's not right because they showed me a definition where engine can be anything that produces power, and electric motors produce power. But it's going to have 3 motors. It's going to have 1 pusher in the tail. It's not going to be a reverser anymore. And it's going to have a pusher on each wing. So it's going to be a tri-motor, kind of like a DC-10. Or an L1011, I can't remember what the 3 engine, I think it's a DC-10. Somebody will correct me if I'm wrong. But the weight, how do I explain this? I want, and I wish I had a diagram or something. So imagine this is the fuselage, this is my wing, and then I got wing that sticks out here. Well, hang on. Okay, so this is the whole wing, okay, on one side of the fuselage. When I take the wing off to store it, I don't want to have a nacelle and a motor with a prop on it and a spinner. I want the nacelle to live on the wing that stays on the fuselage. That way when I put the fuselage in my trailer, both the motors and the tail motor is all part of the fuselage and only the outboard wing. Now keep in mind, the outboard wing is going to have a leading edge device that works. It's going to have spoilers that works and flaps that work. And what I don't want to do is have a nacelle here that has another dead piece of wing, which means I'm going to have to split the leading edge device. I don't care if I have a leading edge device on the inboard of the number 1 and number 3 nacelle. But if I had 4 nacelles on the wings, I would be breaking up the flaps into 3 segments per wing, which would be 4, 5, 6, 7, that's 8 servos just for the flaps. But by having this whole wing with no nacelle in it, I can get away with 3 servos doing 1 long flap. I can have 3 servos doing the long leading edge slat, and I can have 3 servos doing the spoilers. Now there is going to be a little bitty aileron that's 12 inches, and that will have 1 high torque servo on it. But basically the airplane is going to break down so that I have the motors with the propellers and the spinners all as one assembly. I hope that makes sense, because a while back I had a B-29, and the B-29 had the wings slide off the center section of the fuselage, and I was almost breaking the motor mount off or breaking prop blades. because it's hard to transport a wing that has propellers on it without making a special mount for that wing. So this airplane is only going to be 3 motors. Now, you may ask, is that reducing my power? I'm still going to have about 8,500 watts on this airplane, and at its max gross weight of 77 pounds, that's still giving me something like 105 to 110 watts a pound. Now, at the normal operating weight, I'm still going to have 149 watts per pound, which is borderline aerobatic. So I don't think I'm going to have 80 problems power-wise on it. Now, I may change my mind again and figure out how to put a 4th motor back on this, but I've got to figure it out so it stays on the fuselage. There was a concept that I was floating where this nacelle is that has the pusher, have a tractor on the front. So imagine this is the wing that comes off, have a tractor pulling on the front of the wing, have a pusher pushing on the back of the wing, and have that on the left and right wing, and that gives me 4 motors. I have not 100% nixed that idea. Okay, the airplane may end up going back to 4 motors. I need to experiment a little bit more with making a wing center section because I need to figure out with the foam, without building a big mock-up, if it's going to be strong enough to do what I want to do. And I'll lose 2.5 weeks building a mock-up of that nacelle on this project. And right now, I'm barely ahead of schedule again. So I just don't know if I want to build a mock-up of that nacelle, and I may have to do it. So that's really all I wanted to do tonight in this update. I'm really excited on how the horizontal stab is going to turn out. I'm really excited on how the bearings for it is working out. Yeah, I think that's pretty much all I wanted to cover tonight. Oh, I did want to answer a couple of emails. I got an email asking me basically about how to figure out the power system for an electric airplane. Just go on the internet and type in watts per pound RC airplane. You'll see an awful lot of websites already built on telling you, probably I'm trying to think of the best way to say this. Everything about, at least to me, okay, disclaimer for a minute, somebody might prove me wrong when I say this, but everything for me with electric so far, which I've been doing almost 12 years now, is how many watts is that motor pulling? Because watts is power. So if you've got a motor that is made for 3,000 watts, it's pulling 2,500 watts, you have a speed controller that's made for 80 amps, and it's pulling 70 amps, your system is not being maxed out. But then you have to look at what size of propeller you're wanting to turn. So with a 3,000 watt motor at 2,500 watts, and you plug a watt meter into the motor, are you turning the propeller you think you need to use enough RPM to get the prop speed you need to have the airspeed you need in the aircraft? So I know that sounds a little bit complicated, but think about it like this. If you have like on this, I'm going to have, hang on a minute, I'll be right back. It'll take me 3 seconds, hang on. Okay, I'm back. So this is the 3-bladed prop that's going to be a pusher on this airplane. This is a 2114. And the reason you want high pitch in electric motors, because they have such a good torque, you don't have to run really high RPMs. So as you increase your pitch, you'll see your amps go up and you'll pull more watts. But if you're not exceeding the amps of your speed controller and you're not exceeding the watts of your motor, turning a 21-inch propeller, 6,000 RPM with a 14 pitch, if I remember right, something like a prop speed somewhere around 70 or 75 mile an hour. And I might be totally wrong there, but that's what my brain tells. I think I remember. And that's plenty fast enough for a 50 mile an hour airplane. So when you go to size this stuff, there's a little bit of just doing some research into what size propeller do you want to turn. And a lot of the manufacturers that make motors will show their like 2,500 watt motor is you know, put with either like an 1810 or a 2210, things like that. What I do is I find the size propeller I want at the pitch I want, and I start going up in cells on the battery until I max the amps of my speed controller, or I max the watts of my motor. So let's say a lot of people want to run 12S. You might not do it with a big prop with a high pitch because it may be way over amps on you. So most of the time I'm running 8 cell batteries when I'm turning big propellers, or 10 cell batteries. My big FBL forever flew off, that 71 pound airplane flew forever off 10S. And then I decided to really say, okay, what is the maximum? Because I was only going about 150 amps out of 160 amps. So I decided, okay, I'm going to go ahead and take my speed control up to 160 amps. I want to see how much more thrust I got. And 12S was still too much. But I went with 11 cells. So I had a 6-cell battery and a 5-cell battery, give me 11S, and that was the sweet spot on that airplane. On this airplane, I'm almost positive that 8S is going to be the sweet spot. 10S, I could probably do, but it's pushing my motor, which is good for 3,000 watts up to about 3,400 watts. And you know, for 10 or 20 seconds on the takeoff, that's probably not going to hurt a hacker motor. But if it was some of the junk Chinese stuff, well, I shouldn't say junk Chinese because hackers made, even though it's a German company, I think the motors are made in China. But yeah, so that was one email about how to properly size, you know, your power system. The other thing I want to touch base on that I got an email about was how you figure out the wing loading of your airplane. There are so many calculators out there. Just type in RC wing loading. You can type in the square inches and the how many ounces or grams your plane weighs, and it'll tell you right there what your wing loading and what your, both in square footage or square inches, and it will also tell you what the cube, CUBE load is. And the cube load, I'm not going to go into all the math on that, but it's actually more accurate. If you look at what the chart is for cube loading, it will talk about if it's a glider, if it's a fighter. The thing that is always your friend with flying is the lighter wing loads. And I know people think that sounds really simple, but I flew a Zerolic Corsair one time that had a 57-ounce wing load, and it flew like a F-104 Starfighter. I mean, it flew like a jet. So the lighter you can build an airplane, and if I remember right, that Zerolic plane weighed like 48 pounds, and that was just monstrous for that airplane. What is your target wing loading for this year? This wing loading, cube-wise, and this sounds insane, at 60 pounds, which I'm going to call the nominal weight for this airplane, it's going to be a cube load of like 2.3, and when it's at 77 pounds, it's going to be like 3.4, which is still way below a glider. So it's going to be like 27 ounces a square foot at maximum load, and at the nominal load, it's going to be like 22 ounces a square foot, which is like a glider. I mean, that is so light. This plane's going to be really weird. The only thing that makes me nervous about this airplane is how trimmable is it going to be really when I'm flying it. This fuselage is not going to be aerodynamic at all. I mean, this fuselage is a bus. So it's going to be interesting to see as I go faster, do I get pitch tendencies up, pitch tendencies down, which I can try to correct a lot of that with the you know, thrust angle of motors, especially with pushers. And the reason I'm looking down here is I'm just trying to read some of the questions that pop up. But no, when it comes to wing loading, you know, some of my friends from 30 years ago may remember this if they watch this video. I had a Carl Goldberg Cub. I had a Sato 65 4-stroke on it. And it was one of those days at the field where everybody gets bored from flying and it was hot. And somebody said something about, you know, heavy airplanes. I can't remember what the conversation exactly was. But I said, look, as long as you let the plane fly on the wing, you can severely overload an airplane, even a real airplane. It's just all comes down to performance. So what I did is I started taking D-cell batteries. Now this plane, if I remember right, with the Sato 65, weighed something like 6.5, 7 pounds, It was I think it was the Goldberg Cub. It wasn't the SIG third scale or the quarter scale. This was the Goldberg Cub, I think, which was 78 inches, and some people would cheat to make it 80 inches to be IMAA legal. So I had a 78-inch wingspan Cub that I think weighed 6.5 pounds. By the end of the day, I was getting that Sato 65 to fly it full of D-cell batteries between the landing gear and in the front and back seat, and we were flying the plane at 11 pounds. So we almost doubled the weight of that airplane, and I could still fly it. Now, when it took off, the rate of climb was virtually nothing. I mean, I probably never got it more than 20 feet in the air flying the whole pattern when we got it to that maximum weight. But that Clark Y wing was very forgiving when you really overloaded the airplane. And that Sato 65 had a big prop. So I had, if I remember right, it had like a 12 or a 13-inch prop. Maybe it's bigger than that, but it's really low pitch, like 5 or 8-inch pitch prop. So when it comes to, loading up airplanes, taking them off isn't normally the hard thing. It's when people go to land them, they think that they've got to pull the power back a whole bunch. And if it took full throttle to take off and barely climb, you may be on approach at full throttle or close to full throttle, because the moment you pull the throttle back, the plane is going to slow down. So, okay, well, we've been on long enough. So I don't think I'll probably have another update until next weekend, because I got to travel and I got to come back and I'm going to be busy with work. So it'll probably be next Friday or Saturday before I do another one of these videos. I doubt I'll do one tomorrow night, but you never know. If I'm doing something cool and I think I could pop a video up, I try to give everybody at least 2 or 3 hours warning. So thanks for watching the videos, everybody. Have an awesome night. If you got any questions, send me emails or private messages. And that's pretty much it. So everybody have a rocking weekend and take care and be safe, everybody. Bye-bye.